Today's Daily Dose of Math is about how to graph a step function, otherwise known as the greatest integer function, by using the parameters. I have another video where I graph this same step function using a table of values and basically trial and error. So I make a lot of points in my table of values and I'm able to find points that are on the graph and eventually figure out the shape of the curve and get the graph correct. But that is not the most efficient way to do this. The most efficient way to graph this is to use the parameters. We have A, B, H, and K as our parameters. So in our example, A is -2, B is -1/4, H is 3, and K is 6. And using those values, we're able to draw the entire step function. First thing that I'm going to do is use H and K to find a point that is on the graph, and is not only a point on the graph, it's one of the closed circles at one end of one of the steps. H is 3, and K is 6. So we have the point 3, 6 that we can graph now. That point will be right here. Now this is one of those times in mathematics where students have to be careful of signs, because the form is x minus h. So since we have x minus 3 here, our h is 3. If we had x plus 3, we would have to think that's the same as x minus -3, and we'd realize our h is -3. Be careful with the sign of h. With k, it's a little bit more straightforward. We can see that we have +6 here, so the y-coordinate at that point is +6. The next thing to do is to find our b. b is equal to -1/4 in this case. And we need to know that the absolute value of b is equal to 1 over the length of the steps. Therefore, the absolute value of -1/4, which is 1/4, is equal to 1 over the length, so my length is 4. I know that my steps will be 4 units in length, so therefore I either have a step that goes 4 units to the left of this point or 4 units to the right. But we don't know which side it is yet, so we can't draw it yet. The sign of b, though, is what we use to determine whether the closed circle is on the right end of a step or on the left end. We have to know that if b is negative, this closed circle is on the right end of the step. b is negative, we have b of -1/4, so therefore this dot is on the right end of my step. I'm drawing to the left. And I'm drawing 4 units to the left because I know the length of steps is 4. And at the other end I will have an open circle at the point -1, 6. I have a complete step. And you might think that that means I can just draw the rest of the staircase and be finished. But I still don't know the height of the steps, and I don't know whether this staircase is going upstairs or downstairs. I have to find out that information before I can draw another step. The height of the steps is gotten from A. The absolute value of A is equal to the height. The absolute value of -2 is +2. The height of my steps is 2 units. So if I have a step at y = 6, I will have steps at y = 8, y = 10, y = 4, etc. But again, I can't draw them until I know whether this curve is going upstairs or downstairs. That's the next thing to find out. And we find that out by finding the product of A and B. A times B gives us the slope. A times B in this case is -2 times -1/4, and it's equal to +1/2. I have a slope of 1/2. But you might be asking, wait, what slope? This bar is a horizontal line, and that would have a slope of 0. What is it on this graph that has a slope of 1/2? The slope of 1/2 is the slope of an imaginary line that you can draw through all of the closed circles on the different steps. Because A and B were both negative, when I multiplied them I got a positive answer, so I have a positive slope. And that's telling me that this step function is going upstairs. And as soon as I know that information, I can start drawing my other steps. Since it's going upstairs, after this we're going to have another step at y equals 8. So I put an open circle right above this closed circle at y equals 8, and I draw another step that's 4 units in length, which brings us from x equals 3 to x equals 7. I've drawn another step. I can start drawing the next step after that in the same way, but I won't complete it because it's going off of my coordinate plane. I can start drawing this step at the height y equals 4 by putting a closed circle here and start drawing that to the left. And again, I don't complete it because it's going off of the coordinate plane. But I have drawn enough steps on my graph so that anyone who's looking at this graph can see the pattern and could answer questions about the graph even if that person doesn't know the equation. To summarize, the way I use the parameters in graphing the step function is I use h and k to find a closed circle that is on my curve. Then I use b in 3 different ways. I use the sine of b to figure out whether the closed circle is on the right end of the step or on the left end. I use b to find the length of steps. And I use b multiplied by a to find out the slope that's made by these closed circles in the curve. I also use a to find out the height. And once I have done all of those things, I have all the information I need to complete drawing my step function graph. That is today's Daily Dose of Math. Please like, subscribe, and share.